Moving on to the 12th topic, it is to find the absolute extrema of a given function. Before I begin this topic, I want to remind you that this topic is similar to topic 3, 4, and 2, 3, 4. Now, 12th topic is just similar to it. Uh, we have already solved these problems in the previous videos. It is basically we need to find the critical numbers, absolute maxima, minima, and then we need to understand about the graph. But now I had left about, the absolute value function problem. So I will quickly solve our absolute value function problem over here. Now this is the function given. We need to find the critical points, local maxima and minima. So whenever you have an absolute value function, you must remember the critical number. The critical values will be by derivative of f of x, isn't it? So we need to derive and find it. But in this case, also where the sign changes might be the critical points. What I mean is, if this is a graph where the sign changes at the x-intercept, so those also might be the critical points. So basically you need to find this points where the sign changes and then also find the critical values. So let us see how to solve this problem. Now this is given over here. Now here you just equate this function itself to 0 and find the x values. Why do we do that? That is because to find where it changes its sign. Now, what I mean by this is changing sign. Now, a function can change its sign when it passes the x-axis. So those are the values we are solving. So not by deriving, just for this function itself initially. Now we found out x plus or minus 1. And now let's find what are the signs for each of these intervals, because it's an absolute value function problem. Now before minus 1, you can take any test value, say minus 2, minus 3, or over here you can take any value. I can take 0 for example, or 0.5, minus 0.5, and over here we can take again 2. Substitute in this function, that is x square. So minus 2 the whole square minus 1, this would be 4 minus 1. We are getting a positive answer, plus 3. So that means this is positive sign. Similarly, try with 0. 0 square, 0 minus 1 will be minus. And again, you can try with positive 2. It will be 4 minus 1. Again, same thing, positive. So what happens? We are getting positive over here, negative, positive. So this is the basic understanding. This is just to understand how it is. Why? Because this is an absolute value function. Now if you recall absolute value function, anything minus inside, let it be minus x, the answer would be x, or if it is x, it is also x. So this is the reason these are all the extra steps, because we need to split them at different intervals and see what are their functions exactly. Now over here, wherever it is positive, that means we are taking the positive value, x square minus 1 itself. So all the values of x less than negative 1, we are just taking the positive value. Whereas over here also, greater than 1 is also directly x square minus 1. But I told you for minus x, see, even if it is minus x or absolute value of x, the answer is x itself, isn't it? So you need to understand the answers, the functions over here can be two, that is x square minus 1 or minus of x square minus 1. Multiply this minus sign inside, it will be minus x square plus 1. Over here it is written as 1 minus x square. It's the same thing. So this is how we get this function. So when it is minus, just multiply this by minus, and then for this particular interval it is minus. Okay, so now we know the critical numbers over here are minus 1 and plus 1. The sign changes wherever the sign changes, and since it's absolute value function, it is not differentiable. You can't, there is no derivative of sharp edge or a corner, because you will never have a horizontal, there's no derivative, because the slope over here will be 1 1, over here it will be undefined. Basically you don't find the derivative of sharp edges or corner. That is what we had learned in the last term. Now over here, derive these functions. Derive these functions because there are two separate functions. So for this interval, the derivative of x square minus 1 will be 2x. Over here it will be minus 2x, and over here it will be 2x. So now you need to solve, equate it to 0 and find the critical number. These are the critical numbers. That is 1, minus 1, and over here, after we find the derivative, just equate it to 0. For all the cases over here, when you equate it to 0, it will be 0 itself. X is 0 in those particular intervals. So this is how we can solve for critical numbers. And you know how to graph over here only. So now for graphing, it is basic. See, now whatever you directly put the values just shows this is not useful for graph. Sorry, take the graph critical numbers minus 1, 1 and 0. So now what you must do is you must take test values and put over here in this derivative. So this is very important. Don't use this. Over here we just use to see where it is positive and negative. See where it which particular function lies. Now if I'm taking a test value for minus 2, where do I put? X is less than minus 1, that means I have to put over here. At minus x is minus 2, it will be minus 4. So 2 into minus 2 will be minus 4, so negative value is over here. Now for this particular instance, see that is from minus 1 to 1, we have to use this particular value. So now from minus 1 to 1, all these values, let me take 0 and put over here 0. So it will be minus again. Okay, I have done one mistake. I apologize for that. I cannot take 0. Why? Because I've took the equation wrong. I'm so sorry. Now, I cannot take 0. Why? Because it's a critical number. You never substitute critical number back to the derivative because you should get 0. So that is my bad. I took this as the entire equation. Now, all you need to do is take a value within this range. So I'll take minus 0.5. So minus 2 into minus 0.5 will give me positive answer. So this will be plus. And let me take value of greater over here. So it'll be positive 0.5. Say from here positive 0.5. Now let me substitute plus 0.5. You'll get minus. And lastly, let me take 2 over here. Substitute 2 over, sorry, not in this equation. See, not in this equation, it's in this. 2 multiplied by 2 would be positive answer. So now from this graph you can see it will decrease, increase, decrease and increase at the end. So this is the minimum point. Minus 1 is minimum. This over here is maximum. See over here, minimum, maximum, minimum. We can understand from this graphing table. I hope that is clear. So I will just repeat few things. So you can find the local minima. But see, in this, if you do not have the graph, you have to do the trial and test, increasing and decreasing function method. I'll quickly recall this problem. Over here we have absolute value function, so it is not same like the regular functions. First, you need to consider this and make it equal to 0 and solve for x. We get plus and minus 1. And then now check where this function is positive and negative. So when we took a test value less than minus 1, we got positive values, then negative and then positive. That means this positive function is considered over here and over here. See, it's positive. Whereas over here minus, so you should multiply this by minus. Why? Because absolute value functions can either be positive or negative. And therefore it was minus over here. Then derive all these terms at these particular intervals. This is very important because when we do the test, this 0, minus 1 and 1, we take the test values and put it appropriately. Now if I take minus 2, you should put it over here, and I got a negative value. That means it was decreasing. And then when I'm taking a value over here, don't take 0. I took 0 and messed it up earlier. Just remember, critical numbers cannot be put in. If you put in, you should get 0 only. So that doesn't give you any reliable answer. It should be the positive or negative value. So take the value within this range, that is minus 0.5 or 0.25 or anything. Multiply over here, we got positive. Say it will be minus into x is also minus, so it will be positive. Increasing, that is. So these are the derivative. And same thing over here, also take a positive number, more than 0, less than 1. We put it back over here, it was negative, it decreased, and then last one we increased. So this is the thing. Therefore, we know minimum, maximum, and minimum points. I hope this is clear. I missed out initially when I was doing the topic 2, 3, and 4 videos. I missed this problem out. But now, please make sure you are thorough with this. This case is only when you have absolute value functions.